Hello, everyone. So let us continue our discussion on the quantum numbers. Okay. So far, we have understood how to write the various subshell and to know how many orbitals are possible in each of the energy shells. Okay. And we also try to look into the shape of the orbitals as well in the previous videos. Now, after knowing about the quantum numbers, now the next important application of this is how to write the electronic configuration. Now I know that all of you have already studied how to draw the electronic configuration, so it would be just a kind of revision of what you have done. So please follow me while I'm in the video carefully. So let's first concentrate on one of the important principle, and that is Pauli's exclusion principle. Now, what does this mean? It means that no two electrons will have same set of quantum numbers. Okay, so this you can easily understand. Like if we consider one orbital, that is 1s. Okay, if we talk about electron in this particular orbital, suppose we have one electron, okay, in this particular orbital, then we talk about the quantum numbers possible. So we have n, we have L value, then we have the M value, and then we have the magnetic spin quantum number. Suppose we talk about one electron in this 1s orbital, so obviously N value would be 1. Since it's talking about the s orbital, it would be 0. And since L value is 0, means M is also a 0 value. And the ms would be, suppose electron spin can have two values, plus half and minus half. So one of the values would be plus half. So let us consider one of the electron is having a plus half. Now, if I consider another electron, that is second electron in this particular orbit, do not confuse it with any subshell or orbital. I'm talking about one electron and two electron. Okay, so this is the first electron. Let me talk it as first electron. This is the second electron. Okay, so when I talk about the second electron, it would be 1, 0, 0, and minus half. So you see, there are two electrons in this orbital. Both have at least one of the quantum numbers different, and that is the spin quantum number. Now, if I put a third electron here, if I put a third electron here, it would be 1, 0, 0. Okay, but electrons can have only plus half or minus half. So even if I put any sign here like plus half or minus half, then all the four quantum numbers of the first electron and the third electron would be the same, which is not possible according to Pauli's exclusion principle. And that is why each of the orbital can occupy only two electrons. Okay, that was the first thing that I taught you while I was talking about the orbit and orbitals. I told you that the orbital can occupy only two electrons. That is a direct consequence of the Pauli's exclusion principle. So that is another way of defining it. So no more than two electrons may occupy a single orbital, and if two do occupy a single orbital, then their spin must be paired. That means one should be plus half, another should be minus half. So it will be paired up like this. They have opposite sign and they are occupied in one of the orbital represented as 1s in our example that we just now discussed. Okay. Now, what about Hund's rule of maximum multiplicity? This is also pretty easy to understand. So if we talk about P subshell, as we discussed, comprises of three orbitals, and they are degenerate. That means they are having the same energy. So when we have to fill these orbitals with same energy levels, what we do is we fill them till they are fully half filled. Okay, then we will pair the electrons. Okay, so never you fill the electron something like this. നിങ്ങൾ fill ചെയ്യുമ്പോൾ you do not pair them first. Never it is possible. So Hund's rule of maximum multiplicity says that you have to first fill up each of the degenerate orbital singly before pairing them. Okay, so that is what written here. When more than one orbital has same energy, electrons occupy separate orbitals and do so with the parallel spin. So each of the orbitals is occupied with electrons with the parallel spin. So once all the degenerate orbital has been occupied singly with the parallel spin, then the next electron would onwards you will pair them up with the previously filled electron. Okay, so that is about the Hund's rule of multiplicity. Now, what do you mean by Aufbau principle? So Aufbau principle is the basis for writing the electronic configuration. So when you're writing the electronic configuration, you always write in from a lower energy to a higher energy value. So that is how you write the electronic configuration. So this is the diagram that represent how the energy levels are arranged. So please go through this. We will discuss in the class, and we will try to do some electronic configuration using this particular diagram. So you fill the electrons in this format: 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 4s. So something like this. This you have already learned. Probably I'll do one more video with this. Thank you very much for your attention.